Let us take the example of the weight of diamonds and their prices. The weight of a diamond and its price are correlated factors. The price and weight of a diamond are directly proportionate to each other. The greater the weight of a diamond, the higher its price. Observe here that the two variables, the weight of a diamond and its price, move in the same direction, so there is a positive correlation between the two. If there is a positive correlation, the direction of movement is the same. A scatter diagram gives us a rough idea about correlation. To plot a scatter diagram, let us put the prices on axis X and the weights on axis Y. Rearrange the points on the number line. Each point of the scatter diagram represents the coordinate for price and weight of a diamond. Since the line moves upward as we move from left to right, it shows positive correlation. All the points on the scatter diagram lie on the same line, so it is a case of perfect positive correlation. Let us consider the speed of a vehicle and the time taken to reach its destination. The vehicle's speed and time to reach the destination are correlated. As the vehicle's speed increases, the time required to reach the destination decreases. When the speed is 60 kilometers per hour, the time required is 120 minutes. When the speed is 70 kilometers per hour, the time required is 100 minutes. When the speed is 80 kilometers per hour, the time required is 80 minutes. When the speed is 90 kilometers per hour, the time required is 60 minutes. Observe here that the greater the speed of the vehicle, the lesser is the time taken to travel the same distance. Here, the two variables, speed and time, move in the opposite direction, so there is a negative correlation between the two. If there is a negative correlation, the direction of movement is in the opposite direction. The scatter diagram is obtained as follows. Let us represent the time on axis X and the speed on axis Y. Rearrange the points on the number line. The points on the scatter diagram can be plotted by joining the coordinates for time and speed. Since the line moves downward as we move from left to right, it is a case of negative correlation. All the points of the scatter diagram lie on the same line, so it is a case of perfect negative correlation. Let us try to find out the correlation between the height of different persons and their respective IQ levels. What do you think? Is there any correlation between the height of a person and his IQ level? Let us try to plot a scatter diagram for the variables under consideration. Put the IQs on axis X and height on axis Y. Rearrange the points on the number line. The points of the scatter diagram can be plotted by joining the coordinates for height and IQ level. In the scatter diagram, the random spread of the points shows that they are uncorrelated. When we know that two variables are uncorrelated, upon calculation, we may get some value of the correlation coefficient. But the researcher must use proper sensibility while drawing inferences about the variables under consideration. Let us check your understanding of correlation. Observe the movement of the bars and answer the following questions. To fill the blank, click on Try It Out or click Auto Solve to get the answer. As number of customers increase, revenue also increases. That is, the movement of the bars is in the same direction. Hence, it is a case of positive correlation. Observe the movement of the bars and answer the following questions. To fill the blank, click on Try It Out or click Auto Solve to get the answer. As price increases, the demand decreases. That is, the movement of the bars is in the opposite direction. Hence, it is a case of negative correlation. Observe the movement of the bars and answer the following questions. To fill the blank, click on Try It Out or click Auto-Solve to get the answer. As income decreases, expenditure also decreases. That is, the movement of the bars is in the same direction. Hence, it is a case of positive correlation.